My dear students, now we are going to look at the encoder. So in the encoder, if at all we look in, what exactly the number of inputs, number of outputs, what is its origin. So now we will try to look at it. So if you look at the encoder is going to have 2 power n inputs, 2 power n inputs, then n output lines. So n output lines will be there. There will be an enable input generally to enable the encoder. So these are the inputs. These are the inputs. Okay, and these are the outputs. Fine. Now, if you look at this, and if at all you look at the multiplexer, we'll try to understand that. What is there in the multiplexer, as we have studied, 2 power n lines, 1 output line, n selection lines. These n selection lines, right? 2 power n input lines. These are input lines for your mux. This is your encoder. Now you can compare encoder with mux. If I can change these selection lines, actually they are input lines. If I can make it them as an output lines, okay. Anyhow, for multiplexer also enable is there. Here also enable is there, right? N selection lines, if you move this side and you say instead of input if they are outputs. So selection lines has changed it as output lines. Then how many lines are there? Instead of one output line, this will be n output lines. So a multiplexer is converted to an encoder. Okay. So the origin is multiplexer. From the multiplexer, you can understand encoder like this. Okay. A small slight change that is being done to the multiplexer to get an encoder. Right. So now let's take an example encoder. Let's say n is equals to 2. So 2 power n, which is 2 power 2, is 4. So your circuit encoder will become, there is an enable which can be active high or active low. Here I am taking active high. If it is 1, it is on, it works. Now for this I am going to have 4 inputs. 2 power n is to n is 2 power 2 is to 2. You can also call it as 4 line to 2 line encoder. So there will be 2 lines as outputs. Let's say outputs are y0 and y1. Inputs are data lines d0, d1, d2, d3. Now we try to look at its operation. With respect to truth table, we can see the input-output relations. What is truth table is input-output relations. So what are the inputs I have? If you look at the inputs, d0, d1, d2, d3, y0, y1 outputs. Now assuming that enable is equals to 1. When enable is 1, this input-output relation holds good. When enable is 0, always output is 0. Now let's say if D0 is 0, D1 0, D3 0, D4 all are zeros, okay, the output will be 0 0. When input is 1 0 0 0, because D0 line is 1, output is 0 0. When input is 0 1 0 0, output is 0 1, saying that there is a data present on input line D1. When input is 0 0 1 0, output is 1 0. When input is 0 0 0 1, output is 1 1. What I can say is when D0 is 0, output is 0. When D1 is 1, output is 1. When D2 is 1, 2 is 1, output is 2. 3 is 1, output is 3. So what encoder is saying is on which input line the input is present is conveyed through the output line. Is conveyed through the output line Y0 and Y1. Okay. So this is what exactly the thing. But if you look at the case here wherein I have a small issue that will be resolved soon. For all zeros, output is also 0. For 1 0 0 also output is 0. Okay. This is the issue in encoder. To solve this issue, we will be going for priority encoder. We will see what is priority encoder in the due course of time. Okay. Now with this, what I can say is I can write couple of expressions for the output. So if you look at y0, what is y0 expression? What is y0 expression? I will write here y0 expression. What is y0? Y0 is 1 for this, it is 1, here it is 1, when that D2 is 1 and D3 is 1. I can write it as a unique expression as D2 plus D3. And Y1 is 1 when D1 is 1 and D3 is 1. So D1 plus D3. Now I can design a circuit. So how to design a circuit? Let's like this. From these couple of expressions, I'll copy it here. D2 plus D3. Y1 is D1 plus D3. From this expression, what are the inputs we have? So inputs are D0, D1, D2, D3. Okay. So when enable is 1, it is going to work, of course. Let's say D0, D1, D2, D3. So what is Y0 is D2, D3. Take D2 and D3, connect it to OR gate. That I am going to get Y0. You take D1 and D3. Okay. I will connect this. I will connect this to OR gate. Then I will get Y1. Okay. So this is exactly that we are going to have a encoder. So this is how encoder can be designed, right? So how many inputs for the decoder? Encoder? 4 inputs. 4 inputs. What are the 4 inputs? D0, D1, D2, D3, Y0, Y1. These are the outputs. Okay. So this is how one can design an encoder. Okay. So similarly, you can go for any number of inputs. Say for example, on an encoder, I can have 2 power n is to n is to n with enable input. Right, let's say n is equals to 3. So it is 2 power 3 is to 3, which is 8 line to 3 line encoder. So there will be 8 inputs. Okay. There will be 3 outputs. So this is known as 8 is to 3 encoder. It is also known as octal to binary encoder. So we will see this, its operation, its design in the next lecture.